All right, so you should have had for last week, this was, I think this was the first one y'all did. Y'all had to do on your own. You should have had A as your answer. The second one, you should have had J as your answer. I'm assuming that you did this. If you didn't, that's on you. J was your answer for this one. This one was A. The next one was J. Everybody good on that? All right. The next one, which equation represents the statement inverse proportional to S? All right, guys, this had nothing to do with the line of best fit, but it was good to throw in here because we need to review it. You should have had D as your answer for this one. And look, set it up, say it as you set the equation up. R is inversely. Inverse is division. R is, K has to go on top, our constant of proportionality. Inversely proportional to S and directly proportional to the cube of T. Okay? That means that R is two things. So I've got to put it all together. R is inversely proportional to S, which I showed, K over S, and it is also directly proportional to T cubed. So you should have had option D for your answer for that one. For the second one on that page, you should have had F, as in Frank. And guys, this right here, a lot of you asked me about this on Friday. It was ln(x), and all that is on your calculator is the natural log ln right there. And it's right here under log. ln means natural log, okay? So F was your answer for that one. Very simple, very clear when you put those numbers in your list. You did the scatter plot, you saw the plots, zoom stat. It was very clear when you put this equation in, it was that one. It had to be that one. Moving on to the next one, you should have had H as the Bill rode his bike problem. And then for this one over here tucked to the side, you should have had C. And folks, when you put those list of numbers in for this problem, you would have seen a parabolic pattern with your data, which automatically gets rid of A and D. And then you have to decide between B and D, because it's clearly in the pattern of a parabola, okay? And C was the one that fit the best. Going to the next one. Oh, total calculator problem here, y'all. If you forgot how to do this, which number is the index, all that stuff, oh my Lord. Calculator 32 raised to the parentheses, 3/5 power. Hello, 8. We want an SOL full of these. You may have one out of 60 questions, I think it is. Okay, 10 of those are field questions. Now, yes. I'll have to look. It's right over 50%. I say if you shoot for 60% of the questions that you answer, you will pass. And folks, I'm telling you, 400 is, nobody cares. There's not a college one and that gives a rat's hind end whether you got 14 pass advanced perfect scores. Nobody cares except the state of Virginia. Pass them. 400, that's it. And I'm not trying to dumb you down. I'm not trying to encourage you to dumb it down or don't take it seriously. But I'm trying to make you realize a lot of y'all put so much pressure on yourselves, and I am that type of student myself. I am raising a child like that myself, okay? So I get it because you aspire to do great things. There's nothing wrong with that. But in the grand scheme of life, nobody cares. Nobody cares about what you scored on your Algebra 2 SOL, except the state of Virginia wants you to get a 400 so you can get a verified credit. What if you come in and you feel like crap and you take the test and you fall asleep during midway? I mean, it's just, if you fall asleep during SOL, I may come by you and accidentally pluck you in the ear. I might accidentally do that. That would not be a testing rig. No, I would not do that. I wouldn't. I would go, bam, wake up. No, you wouldn't do that, though. All right, questions on these problems at all? Yes. Bill rode his bike. Hush. Let's look at Bill rode his bike. Okay? Let's look at this problem. So, let's look at our lists. I need to clear those out. Remember, do we delete our lists? No, and if we do, we don't panic. We just reset our memory, and they will all be reset. Okay? So just chill. Let's put our numbers in 0, 3, 5, and 8. Put their corresponding y values in. 5, 4, 3.2, 2.9. Okay. I didn't think I put that one in there. Dang it, dang it, dang it, dang it, dang it. Okay, I did. 2.9. Graph, I'm going to zoom 9. Remember, zoom 9 is zoom stat, because I want to be able to see it. Now look at our points for this. It's looking something like this. Let's look at that again. Okay? Or try again. There we go. It's looking kind of like that. I don't know. It looks like a parabola because it's kind of got that curved shape. Do you guys agree with that? But when you look at your equation here, oh, it's not that much of a parabola. Let me move that. Let me ungroup. Time out just a second. Okay, come on now. Let me look at it again. Does it look kind of like that? All right. It's kind of out here. All right, but you can tell, hey, there are no parabolas, so let's check this out. Remember I told you that our diagnostics should always be what? Diagnostics need to be on. So make sure every time you reset your memory, and I know y'all showed me about the D, but it's so much more fun to do this. Not really. Second catalog, which is second 0. Yep. Uh-huh. Okay. Are you sure you put everything in there correctly? Yeah. Did you zoom 6 and it still didn't? The diagnostics. I don't know why that would have had anything to do with it. And I'm telling you that I seriously don't know why that would have anything to do with it. Could have just been a fluke, random thing. But why am I going to do this? Well, if I'm given all linear equations here, then I've got to figure out which one's going to best fit my plot. So if I put that first one, negative 0.2x plus, do you see 4.5 there? 4.5, oh Jesus. All right, folks, this is kind of there. Right? Let's look at the next one. I'm going to graph it with a heavier line just to see if it makes a difference. And let's go with negative 0.2x plus 6.1. All right, definitely that is not an option. Do you guys agree with that? All right, so G is out. Let's try the others. 0.3. 0.3, that must be negative 0.3. Negative 0.3x plus 4.9. That's the first line. There's the second line. Guys, of those two, I feel like I'm at the eye doctor. First one or the second one? Which is better, the first one or the second one? The second one, I think, is closer. Now, that's a judgment call looking at a picture. Do you guys agree with that? That's why we refer back to the correlation coefficient, okay? If we go to Stat Calc, line reg. All right, I'm going to get this out of here. Line reg is going to give us line reg. Stat Calc, line reg. Because it is a straight line. Look at what it gives us. Remember, it's giving me the linear regression line, or the line of regression, for this set of data. You guys with me? So if we're looking at this, this is saying that my equation is going to be y equals 0.27x, let me go back, negative 0.27x, not, that's all right, plus 4.86. Do you guys agree with that? Plus 4.86. Now, guys, what's that close to? I disagree. That's closest to the 0.3x plus 4.9, because if you round my equation to the nearest tenths place, then you're going to get y equals negative 0.3x plus 4.9, which is h. Okay, so there's so many ways to do these problems. Look at it, graph the line, look at the line reg, information. Look at your correlation coefficient. So many different things we can do here. Does that help on that problem? Okay? And then check the last one just for kicks and make sure that it's off. But here's a clue. See where your y-intercept was like 6.1 in the answer G? The y-intercept was 6.4 there. You know it can't be right. It can't be right. Okay? This is like a normal size class, y'all. This is a normal size class. Y'all's class is humongous. This is a normal size. This is odd to see. I know, we're missing too many folks. I hope y'all feel better. So we are looking at normal distribution. This is not difficult at all, and I'm being serious when I say, if I think it's not difficult, it is not difficult, because this stuff blows my mind. Statistics and probability, I cannot stand, makes me want to vomit in my mouth, okay? Or it does kind of make me throw up a little in my mouth. But it is very easy, okay? Things you need to be very sure of. Yes, you did. But in addition to your notes, you also got a z-score table. I feel like most people don't know where their z-score tables are, so that's why I just gave you another one, okay? So I just gave you another one just to be on the safe side, all right? Here we go. Pay close attention. The normal distribution, folks, the first time I ever saw this was in college. Do you know what that curve is called? What it's sometimes referred to. This is sometimes referred to the bell curve. Statistics. This is how a professor explained this to me in college, okay? If you're looking at test scores, the most people, and this is my rule of thumb, the most people, the majority of a class, should be falling in the middle. All right, now think. Our falling in the middle would be scoring what? No. C's. If we're looking A, B, C's, D's, F's, right? So when we're thinking, you don't have to write this, just think about it. In the middle, that's the majority of your folks. They're going to be on either side of C's. The farther you go to the right, what letter grades would that represent? B's, and then the farther you go to the right, A's. Now think, in real life, aren't there fewer and fewer? The farther you go to the extremes of this curve, shouldn't there be fewer and fewer people scoring A's and B's and scoring D's and F's? Okay? In the real world, that's the way it should be. We shouldn't all be scoring A's. Because if everybody in my classes are scoring A's, then I'm not doing something right. I've got to ramp everything up. So, what does all this mean? This is the mean. Here in the middle, I want you to draw that all the way down. This is the Greek letter, and it's a funny looking U. And it's down there at the bottom of that little slide. That's called mu. It's spelled mu, but we pronounce it mu, okay? And that represents the mean, or the average of a set of data. And there are 3 other things that we have to be mindful of. On each side of our mean is a standard deviation, folks, okay? That means, and I don't draw this very nicely, it's supposed to look something like this. It kind of looks like a whistle to me. I don't know. I can't draw it, so I draw it like this, and I put a on it. Let me show you how to do it, how I do it. You are supposed to make it look like that, kind of. I just do it like that. That is the symbol for standard deviation. Stop talking. And that's the lowercase sigma. Okay? I will refer to standard deviation, and I'll draw that little whistle symbol. But it's a Greek letter. Okay. Now, on each side of the mean is a standard deviation. When you go to the right, it's positive. When you go to the left, it's negative. So we have one negative standard deviation away from the mean. And then you come down here and you have your second. All right, so that means it's 2 standard deviations from the mean to the right. We can do the same thing on the left, and it would be -2 standard deviations. And there's another one, which will be 3 standard deviations. If you go to the right, you have to go to the left. And I didn't draw this very good, my curve. I never draw them perfect. But there is one more little piece out here to the edge. And that's the extreme, folks. These are going to be like your way, if you're up here in this portion of this curve, and you're 4 standard deviations away from the mean, you got it going on. You like hundreds. All right, but that's what you're looking at. Now, what does all that mean? It said including all of the percentages, okay? In the middle, this portion here in the middle, there is an area underneath the curve, the standard, the normal distribution curve. The portion that includes 1 standard deviation on both sides of the mean represents 68% of your data. And notice that it goes from 1 standard deviation to 1 standard deviation, 1 negative to 1 positive, okay? These numbers are going to be very important to you. The next set of numbers that's going to be important to you is going to be this, from -2 to +2 standard deviations. That's going to represent 95% of your data should fall within that 95% range. And then, one more. If we included all of the data from -3 standard deviations to +3 standard deviations, folks, that represents 99% of the data that we're going to be looking at, whatever that data should be. Okay? Now, 68, 95, 99. You flat have to memorize that. Period. And I got to thinking when I was studying this yesterday, I was thinking, see, back in the day, a failing grade was a 75, an A was a 95, and an A+ was a 99 and 100. And I thought, I wonder if that had anything to do with the way we got our letter grade, my generation, your parents' generation, because a 95 was an A. It wasn't a 94, it was a 95, okay? 75, you scored a 74, you failed. Something to think about. I want you also to think about this, folks. If you're looking at all of your data, the mean, that mu, should represent how much of your data. If I go from here to here, how much of your data will be represented with that much of that curve? Half, which is how much percent? 50%. So if 50% of your data falls to the right of your mean, all right, think about these numbers, which also means how much falls to the left of your mean? 50. All right, we've got to look at one more thing because we've got to bust this down now. We've got this range of data that's 68%. Let me ask you this. How much percentage is represented from the mean to one positive standard deviation? How much? How come you got 34? Because it's half of 68, isn't it? You got to know this too. Write this down. This little piece, I feel like it's a little piggy. This little piggy is 34%, which means the percentage on the left, one standard deviation away from the mean, is also going to be 34%. How could I figure out what's in this piece right here and this piece right here? 95 minus 68 is 27. What's 27 divided by 2? 13 and a half. Excellent, Anna. So this piece represents, I'm going to erase that, 13.5% on both sides. Very good. Ooh, that looks bad. Bad, bad, bad. 13.5. Let me get something really little here. I don't know that this will do it, but let's see. Nope, didn't do it. Thirteen 13.5. Then what is going to be the little piece right here? What's going to be that little piece? Think about what Anna said. To find 13.5, she took 95 minus 68 and divided it by 2. How much is it? Why? Excellent. 2% here, 2% here. And then I want you to tell me the percentage under that curve from 3 standard deviations to 4 standard deviations. I want you guys to do that yourself. You don't need me to guide you through it. Because, in essence, what is the total amount we want underneath the curve? 100%. Figure out what's on each little end there for me. Somebody said it. It's a half. It's 0.5. Dylan, how'd you know that? %. Now, you're such a forest person. See, Dr. G would be proud of you. What would I do? I would say 2% plus 13.5 plus 34 plus 34 plus 13.5 plus 2, and I would get 99, and then I would take it away from 100 because I'm not a forest person. We're still going to get the same thing. Still going to get the same thing. 0.5%. Those little numbers, folks, if you can grasp the concept, first of all, if you know 68, 95, 99, and then if you understand how to bust those in half, you got this nipped. I mean, you've got this nipped. This is all you've got to know is this stuff right here. 34, 34, 13.5 on each side, 2% on each side, 0.5. Folks, what do you notice about this curve? It's what? This curve is what about the mean? Give me a fancy word for that. Nope. Dylan, explain how you got 0.5 on each side. Which leaves 1%, divide it by 2, and that gets 0.5 on each end. Let me do this. If I were to show you this picture, okay, what? It's symmetrical. The normal distribution curve is symmetrical about the mean, folks. And if you can wrap your head around 34, 34, 13.5, 13.5, 2, 2.5.5, you will not have any trouble with this at all. But you have to know 68, 95, 99. 68, 95, 99. You have to know that. Is it anywhere on the test for you? No. Is it anywhere on your Z-score table? No. You have to know it. Okay? Z-score table, you're going to have to know and keep that for tomorrow. We're not going to use that today, but I wanted you to go on and have it in your possession. Okay? Now, what are we going to do with this? Look at this next problem. It says the manager of a 500-seat theater knows that about 450 people usually show up opening night for a movie. The opening night audience sizes are normally distributed. That's important to us. That means our normal bell curve with a standard deviation of 25 people. This is so easy. How often are there not enough seats for everyone who shows up? And then what percentage of the population would be between 450 and 475 people? And then between 400 and 500. Say what? First thing we have to do is draw the curve. Okay? This right here tells us that it is a bell curve. So, as neatly as you can, draw you a normal distribution curve. The maximum point on our curve is where the mean occurs, the average. I'm going to just draw a line straight down through the middle because it does act as our line of symmetry. Go back into the problem and think, what is the mean? Are we told our average, our mean, 450? It says about 450 usually show up. So that is our mean, which is our mu. I'm going to put 450 up here. Now, you know as well as I do that there's going to be, here's our mu, one standard deviation, positive and negative, two standard deviations, positive and negative, three standard deviations, positive and negative. This is all about drawing this curve and putting information on this curve. Now that I have all those standard deviation things written at the bottom, so what do I do? Okay, here's what you do. It says the opening night audience sizes are normally distributed with a standard deviation of 25 people. This is the easy part. So easy. Watch this. One standard deviation away from the mean is 450 plus that standard deviation, which gives us what? 475. How'd I get that number? 450 plus 25, right? What is the number of the audience 2 standard deviations away from the mean? How much? 500. How come? 475 plus 25. And what is the value 3 standard deviations away from the mean? 525. Do we do the same thing going in the negative direction? Yeah, absolutely. 450 take away 25 is 425. Take away 25 is 400. Take away 25 is 375. And folks, at this point, when I put all my numbers on my curve, because I have to see it, I'm going to draw 68, 34, and 34. And then I'm going to do this. I'm going to go. And see, my curve's not symmetrical. You can see that it's not. Here's 5 here. It ought to be down here. What's my next number? 68 what? 95. So 95% of my data falls here. What goes in this column? 13.5. What goes one more standard deviation out of there? It is 99. But what's the little piece? 2 and 2. And then what's on the outside? On the very far extremes? 0.5 and 0.5. Now we've got our numbers on my graph. I do this every single time. And by doing this every single time, what has it helped me do in less than 2 hours? I've learned my numbers. Okay, I've learned my numbers. Now go back to the problem and read it. It says, let me ask you this just for kicks. Let me think how I need to say this. Where are 50% the audience total numbers? If it's 50% of the data, it's going to fall between what number and what number? Could fall. 50% of the data? Couldn't it fall from 450 to 550? Or 450 to 350, couldn't it? That's when we're talking 50%, you're splitting that curve in half, okay? Go back and look at the first part. It says, how often are there not enough seats for everyone who shows up? Well, how many total seats does it have? It has 500 seats. That's important to us. All right, so if I go here and I look that way, how often, what percentage of the time do they not have enough seats? 2.5%. 2 plus 0.5, which is 2.5%. Does that make sense? Everybody good with that? Look at the next piece. It says, what percentage of the population would be between 450, okay, 450 and 475? How come? Because that's what it says. Oh my. Why can I not do that? If I look at this, y'all, does everybody see that? Between 450 and 475 is from here to here, right? So it's the how much? 34%. That's it. 34%. No, because it says between 450 and 475. All right, so 450 and 475 people, it's 34%. Everybody agree with that? Yes. How about between 400 and 500? 95, how do you know? Because you're looking specifically at, let me see, can I change? Yeah, I can. All right, I'm going to change blue here. Kelly, I'll have this on the web page, homepage, whatever. And you see here, 95% yes. Y'all cool with that? Questions? If you look big picture, you're going to look at the 95%. If you look at the trees like I do, then could I add 13.5 plus 34 plus 34 plus 13.5, and what would I get? I should get 95%. Does that make sense, yes or no? Questions? All right, let's look at the next one then. Eggs. Everybody needs to know about eggs. Eggs are exciting. They're exciting. Ha, ha, ha. What's the first thing you think we're going to do with this? Draw that thing. Draw that normal curve, that bell curve. I'm going to draw it humongous. Maybe. All right, egg production. Number of eggs laid per year by a particular breed of chicken is normally distributed, importante, with a mean of 225. Right in the middle, 225. And a standard deviation of 10 eggs, okay? This is my mean. One standard deviation, and I'll go back to the negative. 2 standard deviations, back to the negative. 3 standard deviations, back to the negative. All right, here we go. What are going to be my numbers along the top of the curve? Going to the right, 225, standard deviation of 10. What's my next number? 235. What's my next number? And the next. 255, right? Everybody cool? Go back the other way. 225 minus 10. 215. 205. 195. Is that it? All right, and now what do I have to do to my curve? And I'm going to do it every time. I don't care what the question asks me. I got to put my percentages in, okay? So that means from here to here, that's 68%, so that's 34 and 34. And then 13.5, 13.5, 2, 2, 0.5, 0.5. Y'all with me? The more you write the percentages, the quicker you will remember them. The quicker you will learn them. Everybody cool with this? All right, let's look at the question. It says, about what percentage of the chickens will lay between 25 and 235 eggs per year? Anybody? Between 215 from here to here. Why will that not do? Ugh. Lindsay, you cool with that?
Yeah, I think it was.
From 215, from here to here. 215 to 235, 68%, guys, yes or no? Yep. And the way you guys may know the 68% number, I'm totally going to add every single time 34 plus 34 to give me 68. What in a flock of 400 chickens, about how many would you expect to lay more than, very important, 245 eggs per year? Where do I even start? How come? Because I'm going from here this way, correct? And that's going to be 2 plus 0.5. Do you guys agree with that? Facile or difficile? Questions at all? Here we go. Look at the next one. Manufacturing. Hey, folks, do this one yourself, please. Lindsay, don't worry. You don't have to worry about them. All right, so manufacturing. It says the diameter bolts produced by a manufacturing plant is normally distributed with a mean of 18. Okay, here we go. My mean's 18. Standard deviation of 0.2, so that's going to give me 18.2 is one standard deviation, 2 standard deviations, 18.4, 3 standard deviations, 18.6. Do you guys agree? 17.8, 17.6, and 17.4. Is everybody cool? Do your numbers match my numbers? Because they should. Now, my mean is here, 34, 34, 13.5, 13.5, 2, 2, 0.5, 0.5. That ought to be a no-brainer for you, and it ought to go that quickly, okay? Now it says, what percentage of bolts coming off the assembly line have a diameter greater than 18.4 millimeters? Holy crap, what is it? 2.5%. 2 plus 0.5, which is 2.5. Here, this way, bless you. Do you guys agree with that? How many of you had it hands up? Excellent. Look at the next one. Did you or did you not? I'm hoping it's a yes. No response. What percentage have a diameter between 17.8 and 18.2? Well, go to 17.8, 18.2. Folks, what two numbers am I going to add together? 34 and 34, which is, how many of you had 68%? Did you have your numbers correct? Questions? This is questions. Do you have questions? You cool? Okay. All right, here's what you're going to do. These three worksheets, yeah. Tomorrow I'm going to have a video on Z-scores. Folks, what's going to happen when we're working on problems and it says, look at this graph, and it says, well, what percentage of bolts coming off the assembly line fall between 17.6 and 18.5? All right, now, some of you just went, what happened? 18.5 is what? Yeah, but is it on my curve? Is it written on my curve? No, it's not written on my curve. So I cannot make an estimation. There is something that we have to do, and we're going to have to standardize all of our data, okay? What that means is we'll have to convert all of these numbers to Z-scores, and instead of looking at 18, 18.2, 18.4, you better be paying attention. You're going to be looking at 0, 1, 2, and 3, -1, -2, and -3, and that's where that table comes into play, okay? I would write that down if I were y'all. What we'll have to do, since our numbers are going to be weird, we'll have to convert everything to Z-scores. That's what happens when the numbers that you're given or the numbers you're asked to find aren't the numbers we write on our curve. We have to convert everything and standardize everything. Folks, that's why you take standardized tests. Okay? Yes? Maybe. Maybe. It's not, I'm serious, it's not difficult at all. Promise. And if it were difficult, I would tell you, guys, you really need to pay attention because this is going to blow your mind. I would be up front with you. You will be fine. Promise. Every one of you in here will be fine with this. It is very, very easy. Okay? That's why, although I want to be here tomorrow, I need to be at home. I'm just banking on the same thing that happened with Nate. It's going to be with Sadie. So I need to be at home. Okay? Remember your percentages. 34, 34, 13.5, 2.5. Okay, you got to remember those. Got to remember that this is very important. At mu, at the mean, at that point on your distribution curve, that's where your mean, median, and mode are about the same number. They're equal. You need to know that. And just out of curiosity, when do you think you get better results? Do you think, well, not necessarily. Do you think you're going to get a better result on a survey if you survey 10 people or if you survey 110 people? The larger your population, large numbers. Your population, those are large numbers. Your sample is like if they surveyed our whole school, but they just took you guys to get the data from. Our class would be a sample from the population, okay? And again, this is all statistics, all fun stuff. It is kind of interesting because this is where we can study trend lines and things. It is very interesting. But on the worksheet, folks, you could do potentially the whole first page right now, but this should be, you need to have it done by tomorrow. I will do my very best in getting every answer for you so that whoever the sub is will go over the answers with you tomorrow. Very easy. You can do this today in another class. Easy. Get on it now, right now.